Okay, let's look at the system now. It is here we have the RAM, and here we have a CPU, the Z80, and here we have the 9 to 5 volt converter that goes into this, which is the clock. The clock we need for running the CPU, and to run the RAM we just need 5 volt, and we take that from here. Okay, so the idea was to try to get these RAM should be able to run by itself, the CPU should be able to run by itself, and there must be an easy way to connect them without making any multiplies on those two. Of course, it's not the optimal way to connect them, but just to show the proof of concept how a computer works, it's better like this. Of course, I get some problems sometimes when I run the program, but to show the basic idea, it's good enough. Okay, so first let me show that the RAM is working by itself. Just quickly here, I need to switch the current on here. Okay, so now we have current on here. So I connect the RAM. You can see. I can refresh it, but let's put something in. The address 0. Now it's saved. Take address 1. There's something else. Let's just put something else there. And you can see if I switch between the two addresses, I have different things. So okay, no problem. So the RAM works by itself. Good. That's it. Let's see about the CPU. How does it work? Yes, you just put the current in here. Okay, and one thing more, we need the clock, and the clock should special place here, and then we just refresh it. Just hold it down for I'll usually wait for I don't know 3-4 clocks, and that should be okay. Now you should see it count up here, the program counter starting at 0. Now it's 1, and it's 2. There it was. And you can see that the yellow here, every time it switches off, it's reading that one. Counting up, and then it's reading. Read. Okay, so when the yellow is off, this yellow, it's reading from the RAM, but it's not connected now. Okay, so this works fine. The input is everything is put in the ground, so it's just counting up. Now let's see how can I connect the RAM and the CPU so that I get the smallest computer possible. Well, it's not that difficult. It takes some time, of course. So I'll just stop the current here. Okay, so the connection we want is between the RAM and the CPU. Okay, so this is the RAM and the CPU. So as I would have said, the CPU has a little bit strange data names. This is 1, 0, 2, 3, 3, 4, 5, 6 and 7. So they are not in series, but the RAM is in series. So what we want is to connect the 1 here with the 0 here, and the 2 should be connected to the 1, and the 3 with the 2, and so on. We have to connect, and then they start here. 4, I think that is here. Yeah. So we have to connect all those in and out, and the addresses also, they are numbered in series. Here, 1 0 to 0 to 0, 1 to 1, and you keep on going. I'm only using 4 addresses because my program is so short. And then the most important one is the read-write here, this one. It should be connected to write here. So my RAM is in default in read, so it's only when I'm writing that this is used. Okay, so this is the connection, like that. So the first thing I would like to do is to take the addresses. I only use 4 addresses because my program is not longer than that. So the addresses on the RAM is easy. Start with this one. I just connect. Now I usually put them together. Okay, so okay, and the next one here. Like that. Okay. You have to be patient. Now the addresses are connected, so now the CPU can fetch data just by showing which address it wants. So now I have to connect the data address, and the data is a little bit strange because if you look at the CPU, I don't know whether you can see it. It's the 1 0 7 2 6 5 3 4. It's a little bit strange because here on the RAM they are in sequence 0 1 2 3 4 5, but not here. So you have to bear that in mind when you connect those. So I start with the input output 0 here, and I'll find it somewhere. It's here. So this is boring, but it's important to do this right. If you make a mistake here, nothing works. The 2 is there, and now I come to the other side of the RAM. This is the 3. The 3. I'm a little bit surprised that this is even working. I don't think this is the right way to connect it up if you want to work. But it seemed to work okay. And the 5 is there. 6. And the last one is 7. It's here. Okay, so you can see now I have connected everything. And the last one is the read-write. So in default it's reading all the time. So by default the RAM is in read, but if I want to write, I need to connect it to this pin here. which is the red here. So when the red goes off, it's writing back to the RAM. Okay, I'm gonna show you that in a moment. Let's just hook it up and see whether it's working. Okay, I just switch this on. Now let me put something into the RAM here. Oops, sorry. And it's important that I have ground here. If I don't have ground here, it doesn't. You have to have ground here, and otherwise you cannot put anything into the RAM. So now I clear the first address, and the second I clear too. But the third, or you will say number 2, I will put a halt instruction in. It is 0 1 1 1 0 1 1 0. That's the halt instruction. Okay. Now it's saved. Okay, so you can see that the halt is active when this one goes to off. So let's try and run it. I'll hold it down for 2 or 3 blink. Let's see. I should start with it's reading 0 first. There. Then it's reading 1. You see, reading. And now it should be reading the halt instruction. Next, yes, there it was. And look at this one. This goes off. Now it's halting. Okay, and you can see that every time it's reading the same address, the 3. Now it's reading here. And it's 3, so it's halting. It's not going up. The program counter is going up, but it's not. It's just reading the same way. Okay. So next, I will put a program in. Okay. Okay. Now I would like to program the computer with this program. It's a very simple program. The first address 00 is just empty, just to be safe, and the first address has the LDA, so add in the register A some data, and here is the data. I will save the value 3 into the A. Then I say load address A to where. So this means that take the value in A and save it in the address that comes here, this one, which is 1000. Okay, so I will want to save this value in the address 1000, and this is the high address. We're not going to use that there, and then we halt the computer. So that I have to program that now. Okay, and it's funny because you can do exactly the same with the Altair 80 8000. It has the same machine code. Okay, so I'm just switching the CPU off here, and I found that the program when I use this capacitor, which gives 1 blink per second, around that, it's too slow. So I need to put a little bit quicker, a smaller capacitor in, so it goes a little bit faster. Then it works better. Okay, fine. So let me start programming it. 0 0 0 is just empty. That's good. And address 1, I need that. I store it. address 2 should be the the value that I want to store, which is the value 3. Now I store value 3 in the A registry, the accumulator. Okay, and then address 3, I should say the opcode here and that one. That's to write to, and then I need to give it the address on the on 6. Okay, and the address we want to store in is this one. Okay, so we want the value 3 to be stored in the address 8. Okay, and the last one then just be 0, and then the halt instruction. Well, and the halt instruction is, I don't know, I don't think we need that halt instruction, but oops, there's something that I'm missing here. Yes. Okay. And then, just to be safe, I want to confirm that the address 8 does not hold any data now. It's empty. Okay. Okay, let's check the program. 000, nothing. And address 1, we have that. Address 2, 3, and 4, 5, okay, and 6 is the halt instruction. Okay, we are ready to go. I connect the CPU and refresh it. I think that's good enough. It goes a little bit quicker now, just to have a look at this halt there. Then we know that we are finished. There. Let's check whether there's something in there. Well, you see, address 8 holds the value that we expected. Okay, so it works perfectly. Thank you.
Okay, what's a little funny here is that if we look at the Altair 8800, we see that it's used a CPU of Intel 8080, and if we look at that, the 8080, it says that Zilog introduced the Z80, which had the compatible machine language instruction set. Okay, so this is the 8080, you can see there. Okay, so this must mean that the same program that I already have run in the computer here should be able to run in the Altair. So here I have the simulator, which is created by this man, Klaus Gilio. Okay, let's try it. Start it here, and then we reset it. Fine. And we insert 0 to the first address. That's okay. So that's just next. Okay, and we insert 1, 1, 1 there, and next. We go and close that down like that, and then we need 1, 1, 1, 1, 1. Yeah, and now we need the new address that we want to store the program in. Is this one? Okay, and then we have to have 0, and then we have the halt instruction, which is 1, 0, 1, 1. Okay, next. And let us look at address go to the next. Yeah, we just go to the next. Okay, so examine, we reset, and we examine next. 3, 4, 5, and the 6 hold, and the 7 and 8. This one should hold nothing. So we're gonna store that, deposit nothing into the 7. Okay. No, 8, sorry, the 8, which is the address that we are gonna save. This is the address here. We're gonna save the value of 3 in it, and there's nothing in it now. Okay, so let's see. We reset and run the computer, and then we stop, and let's so examine. Oops, reset first. You see, at address 8 we have stored the value 3. It's exactly the same. Thank you.